Hello, this is Mr. Agbamu Idana Grenel. I'm here to solve some questions on bearing from your WAEC Past Questions. And this time around, I want to solve some theory questions, some questions that look somehow difficult for us to solve. I've already done some basic questions from objective and some simple theory questions in my last video. So if you go through the questions, you will understand basic introduction to bearing. So this one is also another good one that will help us to understand the topic bearing very well. So I just want us to listen very well and follow everything I'm going to do so that we can solve the question. So let's start. The question is talking about this boy Ayo. Say Ayo travels a distance of 24 kilometers from X. So where you are coming from is very important in bearing. You know, that's what I told us from in my last videos. You see that from where you are coming from, that is where you start. So Ayo comes from X. So let me start with that place. Start with X. Just draw your 4 cardinal points. So you are always facing north. That is the basic assumption in bearing. So if I label this point X, so this is my point X. So that is where I will start from. So and the bearing from this X now is 60 degrees and it's going to point Y. So you are going to turn 60 degrees from north, you turn 60 degrees. Remember this is east, 90 degrees, so 60 degrees should be somewhere here. So you just go up straight. So let's assume the distance stops here. So you go straight, then this is the 60 degrees. Make sure you label it as part of your solution. Alright, then I've told you in our last video, this angle here, 60 degrees, is alternate to this angle, so you always put it immediately as part of your solution. So, and this is point Y. So that means the bearing from Y, when you are going back from Y, you are going to turn 180 plus 60, then you will turn back like this. Y from X, 60, you will turn like this. So this one is settled. So let's continue with the question. We go back. Now say it then travels a distance of 18 kilometers to a point Z. See, they didn't give us the bearing of this turning. The bearing from Y to Z they didn't give us, but all we know that from Y it travels to Z at a particular bearing. We don't know that. So let's just assume any line for that. So that means it's possible this boy from here, it's possible he went straight like this, or it's possible he came down through this direction, or it's even possible he came through this direction, or it's possible he came through the direction. So Z is somewhere around. So let's just put Z somewhere here. Let's just put where we'll have a good triangle. At the end of the day, whatever answer we get, we'll know where it's supposed to be or not. Let me just put it somewhere here. Okay, and that distance is what now? And the distance is 18. Okay, let me make it short. Since 18 is smaller than 24, let me take it somewhere here as 18. Remember the first distance is 24. No, we are doing a rough sketch and we are not drawing to scale here. So this is 24 kilometer, and the second length is 18 kilometer from Y to Z. So we have 18 kilometer, 18 kilometer. Alright, so Z is somewhere here. You draw your straight line. Let me make it straight. Draw your straight line. You go. Alright, so this is point Z. Okay, and what did they say next? We go through the question again. It said, and Z is 30 kilometers from X. So from Z here to X here, I'm going to have 30 kilometers. So if I connect this place, down to this place, I'm going to have 30 kilometer. 30 kilometer. Very, very important. 30 kilometer. Okay. So this is the sketch. So, but now we can't really get the exact location of Z, and yeah, the exact location of Z cannot really be determined. Z can be anywhere, can be here, can be here, can be positioned anywhere until we get the angular turn. So what they want us to calculate now is bearing of Z from Y, so which is very important. So this bearing is what they want us to calculate. So this turning is very important from Y to Z. We need to know it so that we know how you need to turn before coming to Z. Then the other place they want us to calculate is bearing of X from Z. Yes, when you are coming from Z, this place, down to this place, you need to know the turning. Very, very important. So you need to know this turning. Very, very important. So these are the two basic angles they want us to get, from Z to X and from Y to Z. So how do we do that? So we need to get the various angles. By getting the angles, we know what to do. So let's get this angle first. Let's get this angle first. If we can get this angle, if we can get this full angle, let me call it angle theta. If I can get angle theta, then it depends on my result. If theta is greater than 60, so I'm going to take 60 out, then I'll get this result. Then it depends. Let's just get theta first. Depending on what we get in theta, we can determine this result that we are going to get here. So let's find our theta. So how do I get my theta now? Remember cosine rule. Cosine rule is what I'm going to use here. And what does cosine rule say? It says this side facing the angle you are looking for. So this angle is facing this side. So and what am I going to do? That means I'm going to do square 30 first. So the square of 30 is going to be equals to square of 24 plus square of 18 minus 2 times 24 times 18 times cos of this angle. So that's what I'm going to do in this first case. So if I move on now, if I say using cosine rule, so I'm going to get 30 square. 30 square is going to be equals to 24 square plus, okay, let me see the other value. Okay, that is 18. 24 square plus 18 square minus 2 times 24 times 18 times cos the angle we need, and we don't know that angle, that is cos theta. So this is it. So all we just need to do is to solve well and we'll get our result. So if I simplify this one, if I simplify this, if I take 24 square plus 18 square to the other side, it becomes minus. Then we'll divide, let's check our result and divide our result by 2 times 24 times this. So let me just do that here fast without wasting time. So I'm talking of 30 square minus 24 square, then minus 18 square. So this is going to give us 0. Because 0 in this case. Okay, so if this is 0, that means cos theta is equals to 0. That's what it means. Understand? Everything here is giving us 0. That is 30 square. Okay, let me just type it out. That means 30 square minus 24 square minus 18 square. If I divide everything here, so you divide by this value here, which is 2. This is minus 2 times 24 times 18. Okay, so everything here is supposed to be equals to cos theta. So now we have proved that the numerator is 0 and 0 divided by any number is 0. So that means we are going to have cos theta equals to 0. So cos theta is going to be equals to 0. So if cos theta is equal to 0, that means theta is going to be, let's see, that means theta is going to be equals to what now? Theta is supposed to be 1, I think, or is it 9? Let me check. Let's just confirm with our calculator. That means the cos inverse of 0 is what? Cos inverse of 0. Okay, it's 90 degrees. So that means theta is 90 degrees. So I got my theta as 90 degrees. Alright. Sorry, 90 degrees. So if theta is 90 degrees, that means in this our diagram, this full angle here, theta is 90 degrees. That means if theta is 90 degrees, you get what I'm saying? That means 90 minus 60, I'm going to get this place as 30 degrees. You understand? So all these are things you need to put in your diagram. So if this is 30 degrees, that means what is now going to be this bearing now? So the bearing from Y to Z is going to be 180 minus 30, and that is going to be what? You can see it, which is going to be 150 degrees. So we have settled the first solution. So since theta is equals to 90, all you need to do next is you now write, now say therefore the bearing of Z from Y is, the bearing from Z from Y is what now? Okay, so it's going to be 180. Okay, let me use mass mode. It's going to be 180 minus 30 degrees, and that is going to be equals to what? That's equals to 150 degrees. So that is the first part. That is the answer for number 2. So that's number 2 answer. I'll put it in brackets. So the bearing of Z from Y is 150 degrees. You can see it clearly now that we got the full angle as 90. So 90 minus 60 is 30 degrees, and the turning is going to be 150. So take note of that. Assuming we got a value of theta that is less than 60, then we are going to know that this value, this angle, is not supposed to be here. Assuming theta is less than 60, that means the bearing cannot be in this position, because theta minus 60 is going to give us a smaller value. That means our Z is supposed to be somewhere here. Yes, supposed to be somewhere here. So take note of that. Okay, let's try the next question they asked from us. The next thing is bearing of x from Z. Bearing of x from Z. So we are coming from Z now. That means if I can get this bearing here, say from Z to X, from Z to X, which is this full turn. Okay, let me get this angle. If I can get this angle, so it depends. Remember, this is 60 degrees. So if what I get here, I add it to 60. If it's greater than 90, that means our bearing from X to Z is going to be somewhere here. So we are going to, this place is supposed to be downward. But if the value is less than 90, that means this drawing is correct. So we just add, get the alternate angle, and that is all. So let's get this value here. Let me call it alpha. Then let's find this alpha. So the same thing, I'm going to use a cosine rule. So 18 is facing this alpha. 18 is facing this alpha, so that means I'll square 18 first. So if I come here for the third one now, so if I square 18, so I'm going to have 18 square, and it's going to be equals to, so 18 square is going to be equals to 30 square plus 24 square, then minus 2 times 30 times 24 cos alpha. So that is it, and that is going to be equals to 24 square plus 30 square minus 2 times 24 times 30, then times cos alpha. Remember, this is the angle we need. So if I do the same thing here, which is collect like 10, 24 and 30, I take it to the other side, which is 18 square minus 24 square, minus 30 square, then divide the result. I divide the result by this 2, by this minus 2 times 24 times 30. So this result is going to be equals to what? Let's put it there. It's going to be equals to cos alpha. So let me simplify this and see my results. Let me copy it and solve it fast. Okay, so I don't need this. Okay, let me take this out. Yes, take this out. So that is cos alpha is 0.8. So I'm getting a cos alpha is equals to 0.8. That means alpha is going to be, you find the cos inverse of 0.8, which is cos inverse of 0.8. So you can use your calculator to check this and see your result. So alpha is going to be what now? So alpha is going to be equals to, let me check with my calculator and see my result. If I get the cos inverse of 0.8, so it's going to be what? It's going to be 36.869. So let me just take 36.87. So 36.87 have 36.87. So that is alpha. Alright, let's see how it can help us to solve our question now. So 36.87 degrees. Let me check again. Yes, it's correct. Okay, let's go to our sketch. So this alpha in this place now is giving us 36.87. So let's add 60 plus 36.87. So I think this is bigger than 90 degrees. So the actual position for Z is not supposed to be here. That means Z is supposed to be below the east line of X. So that means if I have 60 plus 36.67, so the position for Z is supposed to be somewhere here. So let me just sketch it out again so that we'll understand how the drawing is going to be. So Z is supposed to be somewhere here. This is what I'm talking about. So you can sketch it out again in your solution when you are solving. Let me sketch it very well. So actually Z is supposed to be like this. So this is 60 plus 36.87. So let's add it and get the value now. So that means you add your 60 plus 36.87 and it's going to be 96.87. So 96.87 is this value here. So 96, see, is greater than 90 degrees, 0.87. So 96.87 is this bearing from X to Z. So now what is this result now? The full turn here is what now? This is what we are looking for now. So the bearing from Z now down to X will now be what? So if the bearing from X to Z is this 96.87, so the returning one now is now going to be what? So we need to get this angle. If we can get this angle is alternate to this angle. So if we can get this angle here, all we just need to do is subtract the angle from 360 degrees to give us the remaining angle. And how are we going to do that? So this is straight line, this is 180. So 180 minus 96.87 will get this angle. Then when we get this angle, final angle will now be 360 minus the result, and that is all. So I just need to come here and complete our solution. So just say 180 degrees minus 96.87, you get 83.13. So that means this angle here is 83.13. So this angle is 83.13. If you get this angle is alternate to this angle at the top here. So this is 83.13. Take note of this. So by the time you get this, so 360 minus 83.13 will give us the bearing from Z down to X, and that is the end of this solution. And to conclude the work now, I just need to say, therefore the bearing of X from Z is so 360 degrees minus 83.13, and that is going to be what? That is going to be equals to what? Let me do it here. 360 minus 83.13, and that is 276 to 76.87. So that is the answer. So this is the answer to this question 1989 number 11. It's a theory question. So that is all with that. So you can see the diagram. Now. So if I want to make the diagram very neat now after getting our answers now, you say draw the diagram to show the position of X, Y, and Z. Now that I've gotten my perfect result and my answers are okay, all I just need to do in this case is to resketch it and position everything very well. And if I want to do that, I need to go to a new paper. If I go to a new paper, you have this here. Then you have Z is going to be down somewhere here. So that is it, and that is X, Y, Z. So that is X, Y, and Z. So this one move to this place at an angle of 60 degrees. This is 60 degrees. Take note of that. Then this one turn to this place. It turns at an angle of, let me see my answer again. It turns at an angle of 150 degrees, which is this 150 degrees. Okay, this is 150 degrees. Take note of that. Then finally this one, so z, from z to x, it turns at an angle of 200 and, let me check the result again, 276.87, 276.87. Okay, so this is the actual position of the bearing. You can put in your values of the length, 24, 18 and 30, and that is all. So that is the end of this question. 18 and 30. So that is it. So I hope you understand all we did in this video. I hope you followed it very well, and that is the solution to this question 1989 WAEC number 11B. So thank you for watching. Okay, sorry, before I go, let me demonstrate this question using a scale drawing. In case you are drawing to scale, how will your result look like? Let me use GeoGebra to demonstrate this so that you understand it very well. So I have my 3 points, you can see them, X, Y, and my Z. These are my 3 points. So these are my angles I can turn. So let me not waste time, let's go straight. The question says from X to Y I turn 60 degrees from X. So let me turn 60 degrees from X. No, this is my solving. Okay, from X, so let me turn 60 degrees. Just watch this angle, the way we turn. This is my point X. Let me put it here. So 60 degrees. 60 degrees. Okay. Oh, so this is 60 degrees. So let me connect with my line. So from X to Y, let me put the length so that I can measure it at once. So the question says from X to Y is 24 kilometers. So let me put it there. So that means if I move at this angle, so let me move it to 24 kilometers. Okay. Okay, so we have gotten it. So from X to Y, you can see it from X down to Y, 24 kilometers, which is 24, and the angle from X is 60 degrees. So this is settled. Then let's move on. Then we don't know the bearing of Z. Z is located somewhere. We really don't know where Z is located, but we assume somewhere here to be Z. So let's see if we can get it. But the distance will help us to locate our bearing that the question requires from us. So what is YZ? So it then travel a distance of 18 kilometers to a point Z. So Y to Z is 18 kilometers, then Z to X is 30 kilometers. So Y to Z is 18, then Z to X is 30. So let me connect them with my line. If I connect this to this, connect this to this, let me put the distance so that we can find it. Yes. Okay. So this is this. So let's look for 18. So 18 on this side, then 30 on this side until we get the required value we need. So okay, this is 30 on this. Oh, I've gone too far from here. Okay, this is 18. Let me go gently now. To move, let me use my keyboard to move gently. So okay, let me go like this. Okay, let me rise up. Okay, so I want to really get it. Let's just take time and locate it. So I've gotten 18, so I'm in 29.8. No, and let me achieve 30 on this side. So I've gotten 30, so I need to get my 20, my 18. So I'm just very close now. I'm just very close. Okay, because of time, let me start. This is 18.01, very close to 18. Then this is 30. So at least an approximate value. I will get my result now. So the question says we should find the bearing from Y to Z, and I got 150 as my answer now. That means from Y, I'm saying if I turn on this angle from Y here is supposed to be 150. So let me turn so that we can see it. As you turn, just watch the angle as I'm turning. Just watch. See down 150. You can see 150 straight to Z. You can see that it's very perfect and correct. Just a small value we have the approximate value here. Then if I turn from Z down, which is this, I'm going to get this same result. Let me check my answer. I'm going to get 276.8, at least approximate value of this. So I'm targeting 278 here. So just watch as it's turning. Just watch this value here. As it's turning down. Okay, till it gets to this place at 276. We'll stop. So we are very close. Yes, so you can see it's just an approximate value, 277. Even 276 is very close. If I zoom it out and see it clearly here, I see it. So it's even 277 that touches the value, the point we need straight. So that is it. So our calculation, you can see that our calculation is correct, 276.8, which is approximately 277. So this is all. I think you understand everything I just did. So you can use your scale to do this if you don't want to calculate with your cosine rule. So that is all for this particular video. Do have a nice time. Take care.